Alright, John, I'm back. So I found out that YouTube will only post 15-minute videos, so I'm going to have to stop every 15 minutes. So, alright, next part. Now we're on to the 45-degree family. But before I do that, why is this not? Okay, there we go. Before I do that, what we need to do is learn something that's called the magic table, and the magic table is going to help us figure out the special angles and the reference angles that you need to know. So this is something that everybody had to learn, everybody has to remember how to make. This is so important. You need to know how to do this for your region. So let me show you how to do that. What you're going to learn, and I'm going to go over it in a second, is that we memorize the exact values for our quadrantal angles, so 0, 90, 180, 270, and 360. We memorize those by just looking at our unit circle. We also will know the exact measure of the values of a 30-degree angle, of a 45-degree angle, and of a 60-degree angle. We're going to know those exactly. And what I mean by exactly is that there's radicals involved. So these aren't numbers that you can just get out of your calculator. If you just type this stuff into your calculator, you're going to see this huge long decimal. If the test wants an exact value, they need to see radical 3 over 2 or radical 2 over 2, something like that. Okay, so we're going to memorize the exact values for 30, 60, and 90. Then they have like something that we call like cousin angles in the other quadrants, and I'm going to teach you all about that. But the first thing that we need to know is the exact values of 30, 60, and 90. So this is what we call the magic table. You need to be able to remember how to do this. I need you to write this down as I'm doing it, okay? So this is how the magic table goes. First time doing this on a computer, so bear with me. Go away. Alright, magic table. What you're going to do is you're going to write sine, cosine, and tangent right on the left-hand side. It's really important that sine comes first, then cosine. If you get them backwards, if you get them upside down, then these values are going to be wrong in the table. Okay? So it goes sine, then it goes cosine, then it goes tangent. If you're having a hard time remembering how that goes, just remember that sine divided by cosine is equal to tangent, so the sine comes first. Okay? Now we need to know the exact value of 30 degrees, 45 degrees, and 60 degrees. And we call this the magic table. It's really magical. Magic table. I don't know if you were there the day that we did this, but I'm going to do it anyways. Magic table. So here's how we make the magic table. There's a couple of steps. It's really easy to remember. Here's what you do. All along the first column, or the first row, you go 1, 2, 3, and then in the second row you go 3, 2, 1. Okay? Divide everything by 2. And then the last step is to put a square root or a radical over the 2's and 3's that are in the numerator. So there's a 2 in the numerator here. There's a 3 in the numerator here. Not over the 1, because the square root of 1 is just 1, so that's kind of pointless to put it over there. So just over the 2's and 3's. Okay? That's the first part of my magic table. So this is how you use it. The sine of 30 degrees is 1/2. The sine of 45 degrees is radical 2 over 2. The sine of 60 degrees is radical 3 over 2. Okay, so this is exactly what you're going to do on your test to figure out what the exact value of 30, 45, and 60 degrees are. Okay? Cosine of 30 is radical 3 over 2, and so on. So remember what I told you, that the sine divided by cosine is equal to tangent? So Miss Tompkins actually went through and did this out the long way for each of these values. So I'm only going to do it once because you have more important things to worry about. So let's figure out what the tangent of 30 degrees is. So tangent is sine over cosine. So the sine of 30 degrees is 1/2. Cosine of 30 degrees is radical 3 over 2. So that's a complex fraction, okay? It's a fraction divided by another fraction, and the way that we simplify that out is we're going to multiply by the reciprocal, so 2 over radical 3. Multiply on the top and bottom by 2 over radical 3. Everything down here just cancels out, and then you multiply across. So 1 times 2 gives me 2. 2 times radical 3 gives me radical 6. Or actually, no, sorry. I think I'm losing my mind. Gives me 2 radical 3. Okay, so I have a 2 on the top and 2 on the bottom, so I can cancel those out. So the tangent of 30 degrees is 1 over radical 3. But I think that you were there when we learned about radicals, and you can't have a radical in the denominator ever. We have to rationalize the denominator. So what you're going to do is multiply the top and bottom by radical 3. So the real tangent of 30 degrees is radical 3 over radical 3 times radical 3 is just 3. Oh my gosh. So the tangent of 30 degrees, radical 3 over 3. Unfortunately, there's no easy way to do that. Okay? Pretty much what I do is I do the 1, 2, 3, 3, 2, 1 method for sine and cosine, and then I just have the tangent ones memorized because I don't want to go through and do all that work every single time that we have a test. Okay? 45 is actually really easy because it's radical 2 over 2 divided by radical 2 over 2. So it's something divided by itself, so that's just 1. Okay, because sine and cosine are the exact same for 45 degrees. And then this is radical 3 over 2 divided by 1/2, and that happens to be radical 3. Okay? So unfortunately, this bottom row you're going to have to memorize, but this is what we call the magic table. I'm going to come back and refer to that a lot. Okay? So let's go to the next page. Let's talk about the 45 degree family. Why don't these things ever go away? Alright, 45 degrees. So let me see. I have to stop every 15 minutes, so I only have 6 minutes left for this video. Alright, so if this angle is 45 degrees, then we know that the point right here, the coordinate, the point on the circle right there, is the same thing as cosine of 45 degrees, comma, the sine of 45 degrees. So let's go back at our magic table, and you should have that written out right in front of you right now. The cosine of 45 degrees is radical 2 over 2. And the sine of 45 degrees is radical 2 over 2 as well. Okay? Now what do I mean by the 45 degree family? The sine and cosine of 45 degrees, that's something that we have memorized. And then we can use that information and kind of expand that into the other quadrants as well. Okay, so let's see, if we have this line right here in the second quadrant, and it's going to be a cousin to 45 degrees because the 45 degree is going to be known as what the reference angle. So if this angle right here is 45, see, that's why 45 degrees is actually the reference angle. But how can I figure out what this whole angle right here from here to here is? I don't really care that that's 45 degrees. It just helps me figure that out. But in order to figure out what the actual measure of that angle is, I do 180 minus 45, which is 135. So 180 minus 45 gave me 135. Okay? So we call 135 degrees a cousin, or like, you know, it's in the same family as 45 degrees. And the reason why we say it's in the same family is because the coordinates of this point happen to be the sine and cosine of 45 degrees. The only thing that's going to be different is, you remember how we said that the x values in this quadrant are negative and the y values are positive? So that means that the cosine of 135 degrees is actually going to be negative radical 2 over 2. And the sine stays positive in this quadrant, so it's just going to be positive radical 2 over 2. Okay, so that's in the second quadrant. In the third quadrant, both the x's and the y's are going to be negative. So we have this angle right here. And we say that that one is also in the 45-degree family because this angle is 45 degrees. I don't really care what that is. I mean, it just helps me figure out what family it's in, but I really want to know what this whole angle is from here to here. So how would I figure that one out? I know that this line straight across is 180 degrees. It's 180 degrees plus 45 more. So 180 plus 45 this time. What does that give me? 225. Okay, so if I want to know what the sine and the cosine of 225 degrees is, I just think about the fact that the cosine of 45 degrees is radical 2 over 2, but because we're in the third quadrant, we're going to do negative radical 2 over 2 because the x's are negative. And then the sine is going to be negative as well. So hopefully this is making some sense to you. If it's really confusing, you can stop, you can ask me questions or Skype or call me or do something, but I really, really, really need you to understand this, okay? I only have 2 minutes left on this video, then I have to stop. So then we have the last angle right here, and it's actually 45 degrees from there to there. So if I want to figure out what that whole angle is going all the way around, I know that one full circle is 360, so it's 360 minus 45, which is 315. Okay, so the cosine of 315 degrees is the x's are going to be positive, so radical 2 over 2. And the y's down here are going to be negative, so negative radical 2 over 2. Okay? Alright, so I have to stop this video in 1 minute, but this is what we're going to do. We're going to learn the exact values of the sine and cosine of 30 degrees, 45 degrees, and 60 degrees, and then we're just going to show that we have cousins to each of those angles in all the quadrants. Okay? So I have to stop, and then I'll make you another one.